But that was the first traffic signal, and this was actually the patent that he received. Well, traffic signals then and now. I got out in civil engineering and I started working on College Station's traffic lights in '79, and this is what they looked like on Texas Avenue. They were what they called electromechanical. You had an electric motor that every time it turned around once, all the copper contactors that were turned on and off with that motor caused the lights to go from green to yellow to red, all the way around the intersection. Now, I'm going to come back to that motor because one revolution of that motor is called a cycle. Okay, and this, is, of course, is what they look like today. When I was working at the city, we computerized all the traffic signals around A&M. And I worked for the city for 10 years before I moved to the Dallas area. Traffic engineers, we're very concerned about what we call volume and capacity. Okay, the capacity at the traffic signal is determined by how many lanes you have. And of course the volume varies by different times of the day. You noticed how in that earlier picture there were 3 motors in there? Well, that's because you have different traffic in the AM, the off-peak, and what we call the PM peak. So you handle the traffic differently during those 3 times of the day. But lane capacity is dependent on your volume and the cycle, the time it takes to go around and service everybody once, and the green time that you give during that cycle to each direction. There's a value called lane saturation, which on a freeway, if you don't stop the cars, it's about 2,000 cars an hour. When you run the cars through a traffic signal, you're turning the valve on and off. So if you think of it like a pipeline problem, you've got this big pipe with a valve that you're throttling with the traffic signal, and you're, it's how full the pipe is at different times of the day, right? That's how volume and capacity are related at a traffic signal. When you look at a traffic signal, the arrows are numbered with odd numbers, 1, 3, 5, 7, and the throughs are even numbers. These 8 phase numbers have been used for about 50 years. Okay, so every separate movement at a traffic signal is given one of these numbers. Okay, I can see y'all getting into this. Y'all are drivers, right? Y'all are traffic engineers. And you'll probably be the ones programming this stuff for the next 20 years after I'm gone. So okay. But when you look at a traffic signal, you always have 2 signals on at the same time. If you go from left to right, typically on the major street, you have your arrows come on first, and then the green balls, and then you change the right-of-way and go to the cross street, and the arrows come on, and then the green balls. We call that a sequence. So traffic signal controllers number everything according to a phase number, and the operation is what we call a dual ring sequence of sequencing through those 8 phases. That's how all the traffic signals work. Today they're a computer. You have inputs and outputs. You have metal detectors in the roadway or cameras that detect the vehicles. Those are inputs. You push the PED button, that's an input. The outputs, of course, are the different displays that turn on and off. And you have a dedicated controller that's controlling those things. Within that controller, you have different timing that goes on. The greens typically have what we call a minimum green. You don't want to run a green that's half a second, right? You have some minimum time that it's going to time out. But then the green can extend based on whether there's vehicles on the detectors. Of course, the yellow time is a fixed amount of time that we give for safety to allow people to come to a stop. And walk times are constant. Everybody's always confused about why the little white man doesn't stay on long enough for them to cross the street, you know. But that's just to tell you when to start your walk. And the flashing hand, which now counts down, that gives you enough time to safely cross the street. So, two things about signals is the cycle is the time to go around and service one time. How we split up the cycle among the 8 competing directions, those are called split times. And we have something that we deal with called coordination. Right before lunch, we had a good talk on POSIX time, modules, and the way the lights are synchronized is that every traffic signal controller is synced to midnight at the same point. And so that cycle counter at each intersection is synchronized to midnight. And there's a sync point within that cycle that allows you to have a coordinated movement if every traffic signal along your arterial is timing the same cycle length. So these are green bands. This is called a time-space diagram. It's what we use to time the traffic signals. And if you take distance divided by speed, if you remember from physics, the slope of that line is speed. Yeah, distance divided by time. And so those are green bands that we try to synchronize the lights up and down the street to provide as wide of a green band in both directions as we can. That's something called coordination. We have other things that interrupt the traffic signal. Preemption. This signal right out here, during lunch, a train came by. And that caused the traffic signal to go through a sequence that gives a green to clear the track before the train actually arrives. And anyhow, preemption is another thing. Okay, so this gets into, this is the traffic signal controller that the city of Richardson, the city of Dallas, city of Fort Worth, and Irving selected about 3 years ago. And somehow I got tagged with testing this piece of equipment, which was brand new. The company's only been out 4 years. It's got embedded Linux in it. I started testing it, and we just got the first controllers out on the street in Dallas about 2 weeks ago. We've had a lot of bugs to work out the last 3 years, and I've been the one to send in the bug reports. I found out that they included this log in the controller that puts out a timestamp every 1/10 of a second, anytime anything changes. And just sitting there on my desk, it was over 200,000 records a day. And it was in a SQLite database. And I started looking at, well, you know, I hadn't written a program in about 8 years. And I started looking at how to deal with this. And anyhow, I started working with Python, and the folks at the Dallas Users Group. I started going to the meetings every month, and you know, I've written half a dozen different programs, and I've really surprised myself. Python is very easy to use. I mean, I go way back. I've dabbled in programming back since the early 80s. And I mean, I thought Pascal was easy to use, but this, this is, it's great. So this log was in the controller, and it was developed at Purdue. And if you look at the specifications, you've got a POSIX time stamp, and you've got an event code, and the program, there wasn't any software to take this log and make any sense of it. And then I needed something to help me debug this thing. So anyhow, this was the spec. And if you look here, this is why I was telling you about phases, right? And about pedestrians and rings and barriers and, this is what I deal with. Coordination. This log tells you every time a vehicle hits the detector, and when you can associate that with greens that turn on and off. You can tell if the traffic's getting there during a green or a red. And what you want is you want your lights synchronized to where all your traffic's getting there during the greens. We call that good signal progression rather than during the red. And so these logs have got a lot of potential to really help people in my industry. It's just that nobody's figured out how to use them yet. UDOT's been using it. You can go on their website. They're getting what they call performance metrics from the log. It's the guy told me it was a ASP program with about 100,000 lines of code or something, and I don't know. I didn't want to mess with it, but they're getting similar graphs of when the vehicles arrive. Do they arrive during the greens or the reds? This is a SQLite log. Of course, SQLite is built right into Python, and it was very easy to. The company was using PuTTY to upload these files, and it was so doggone slow. But I found a program called SCP or WinSCP, and it's got a command line interface, and so it was real easy to shell out of Python and run this command line program and pull the database out. Once I had it in Python, I could start analyzing it. Okay, and so this was very helpful to me. When I first started with Python, I'd used TickleTK before, and so I tried using Tkinter, and my user interface was becoming so complex, and it really looked cheesy. I don't know. So I looked around, and this Qt with the Pyside distribution of Qt, that's what I started using, and it had this designer in there, and so you lay out all your controls and everything, and save it in a user interface file, and then you run this command line Pyside UIC, and it creates a Python class that encapsulates all that stuff. And so that was my user interface, and then you just import it, and boom, it's in your program. Okay, I'm telling a lot of you guys stuff that you already know, but from an old procedural guy, this was really cool. I started to enjoy Python because, I took 3 ANSI C classes. I can go back to code I wrote 20 years ago. I can't tell you anything about it, even though it's all commented. It's all pointers and junk, and it's like cross stitch. You know, if you want to get down into each thread, you know, but Python, it's more like quilting. You know, you get you a big old pretty square that you want on there and you just grab it and stitch around the corners, and that's what I like about Python. And the code's self-documenting. I mean, I comment on my code a lot, but I've gone back into stuff I wrote a year ago and I can tell what's going on. So anyhow, y'all know that. And Qt also has something called WebKit, which I found real useful. But Qt basically works your user interface, you import it, and then anything in your user interface that triggers a function, what I found what was happening was my program was just kind of, that whole screen was going blank. The whole time I shelled out and ran WinSCP, and when I was doing long computations, it just all went white. So then I found out about worker threads. And so what you have to do is the user interface has to call a function that spawns a thread. And then the thread is where all your work is done. And while that thread's working, you can still go back into the user interface and it's still alive. It doesn't just freeze up on you. Well, that was something I learned. But the people at the Python users group in Dallas, they helped me through a lot of this stuff. I just show up at the meetings and they were glad to help me. Another thing I learned, traffic signals that I was testing, they could grow to like 300,000 records a day. And I was wading through all this text and I was concatenating all my text. And that thing was so slow. But I kept looking on the internet, and somebody, sure enough, they said, don't concatenate that text. It's too slow. Use this join, because text is a list. So I went back through there and I started using that join, and it was a lot faster. The program is useful now. I use it all the time. But that, you know, those are just little things you learn when you when you're new to Python. So that's my final user interface. I have everything in text boxes because when I find bugs, I can cut and paste what's going on and send it to the developer. I've sent him over 1,000 emails. They hate my gut. They hate my guts by now, but they still got a lot of bugs. But I split all those events up into tabs that grouped it in things that I was looking for to find problems with the traffic signal controller. And I put a help menu in there. The owner of that company, I've been arguing with him for 3 years. He doesn't give documentation out. He doesn't even have a user's manual. I mean, he told me to my face that he doesn't like giving out documentation because it helps his competitors. Well, this guy's only been in business for 4 years. You know, wait till his phone starts ringing, right? The guy right before lunch made one of the best points I've heard. Your program's only as good as the documentation that you put together. And so if you run my program under Help menu, it uses QtWebKit to spawn a little HTML window. Okay, and all the documentation that I did it with something called Sphinx, which builds a web page, which I display with QtWebKit. So I've got, you know, example files and all this documentation in there. And, you know, I agree with the fellow that, you know, especially traffic engineers, we're not as savvy with computers as y'all are. So we need a lot of help. So make sure you give us help when you put things together. The other thing I did to complete my program was I used a wrapper called CX Freeze. I wanted it to be cross-platform because you can basically build executables, and our Office is Windows, but I like the Mac. But you can compile in different operating systems. And you basically build this setup file to wrap it Python so the end user doesn't have to have anything on his computer. This was a little script I wrote that compiled the files and put everything together. So now if I'm changing code, I run this build script, and then when I'm through, I run it through this Inno setup file. So the other people I'm working with, I just give them a Windows setup file they can run on their computer. So that's kind of what I've put together this year, and I'm using the heck out of it. So I put it up there. I know the fellow at Purdue, and some other people are starting to, I put it up there on GitHub. You can download all the source and everything. And so I've been trying to work with people to, give it away or get some people to help me work on it. But I really surprised myself the last year and a half what I've been able to do with Python. I really like the language, and like I say, I told the guys in the group, so I'm not going to teach anybody down here anything about programming, but hopefully I did answer your question on how traffic lights work. So yeah, no matter where the future takes us, there will always be a need for traffic signals and high-resolution data from traffic signal controllers. So hopefully that's been entertaining for you.